Hello. Today we're going to take a look at proving trig identities, and I'm going to show you some places where your algebra is going to intersect your trigonometry. Let's go. So here's the identity that we are going to try to prove. And the first thing to know about proving identities is it's not like solving an equation. You do not work with both sides of the equation. You pick one side. And in general, you want to pick the more complicated side. So between this side and this side, I'm going to say this side is more complicated. And part of how I'm making that decision is there's nothing really to do over here. I don't see any identities, any squared terms. I don't see anything I could convert back to sine and cosine. But over here, I see a lot of stuff. I see something squared, which means that's part of a Pythagorean identity. I see a cotangent, a cosecant. Those can be switched to sine and cosine. So I'm going to start over here. All right, now, there are lots of ways to get from point A to point B. For me personally, when I look at this, the first thing I notice is that there's a squared on this side of the equation, but there isn't one over here. So I kind of want to get rid of this squared. So I'm going to factor a single cosecant x out of this term and out of this term, and that's going to destroy that squared. So when I factor cosecant x out of cosecant squared x, I'm left with a cosecant x. And when I factor a cosecant x out of minus cosecant x cotan x, I'm left with minus cotan x. And so now I'm going to take each of these three items and I'm going to rewrite them in terms of sine and cosine, because over on this side of the equation where I'm trying to get, it's written in terms of cosine. Okay, so that represents two different tricks to have up your sleeve when you're figuring out how to prove trig identities. The first trick is if you have a factor that's common to both terms, you could consider factoring it out as a way to start to sort of loosen the knot. The second trick is that if you have things that are not in terms of sine and cosine, you can always convert everything to sine and cosine. Okay, now we're going to take a look at another algebra. It's not a trick, but just reminding you it exists. We have two fractions. They have the same denominator, so I can actually turn that into one fraction. And now I would go ahead and do this multiplication. Okay, so I've moved from here to here. And the question is, where do I go now? Well, one of the questions I like to ask is, what does this have in it that I don't need for this? And the answer is a sine. This whole thing's in terms of cosine. So my Pythagorean identity tells me that sine squared is the same as 1 minus cos squared x. Now, here's the next trick to have up your sleeve. 1 minus cos squared x or 1 minus sine squared x, those are difference of squares. They're factorable. And that is advantageous because you can see what's on top and you can see what we want on the bottom. So when we factor our difference of squares into 1 minus cos x, 1 plus cos x, the 1 minus cos x's cancel, and we're left with 1 over 1 plus cos x, 1 over 1 plus cos x, QED. Now, I want to remind you, I could cancel these because that's a whole term and that's a whole term. I cannot cancel the 1 and the 1 because this is connected with subtraction, not multiplication. I can't cancel a cos x with a cos squared x. These are connected by subtraction, but I can cancel this whole term with this whole term, which is connected by multiplication to its other term. All right, so quick recap. Hack number 1, I decided to factor something common out of both terms in order to blast away a squared. Next, I decided to convert everything to sines and cosines because my answer is only in terms of cosine. I then did some algebra work to combine my fraction, to multiply in my outside, and then I said, all right, what's in this that I don't want in this? It's a sine squared. So I did a substitution, and this is your final hack. 1 minus something squared is a difference of squares that factors into 1 plus and 1 minus. I canceled and I was left with what I was looking for to begin with. Okay, stay tuned for more videos giving examples of how to solve trig identities, showing you different hacks and algebra skills to remember to include as you're working through your trigonometry. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.